Good afternoon. I think we can go ahead and get started here. Thank you everyone for joining us here today. This is the webinar, Math, Reasoning, and Representation, Algebra Instruction that's Ambitious, Meaningful, and Effective. This afternoon, we'll be learning a visual approach to teaching algebra, a methodology presented in the new book, Making Algebra Meaningful by Nicole Fonger, which was published by Teachers College Press in 2024. So on behalf of the publisher, Teachers College Press, my name is Emily, and thank you all so much for being here. I'll just go over a few details before I turn it over to Dr. Fonger for the presentation this afternoon. Just by way of a very brief introduction of the work we're going to be looking at, we know that an essential understanding of the uses and practices of algebra remains out of reach for many students. And concerningly for those students who struggle, we also know that algebra can be a drop-off point in their math education. So it's crucial for educators to have resources that can support math literacy among all algebra students, and that all learners can come to experience algebra as meaningful. This book, Making Algebra Meaningful, does just that. It shows educators how to design algebra lessons that are responsive to all students' experiences. Using examples from ninth grade algebra classrooms, it presents a highly visual approach that will, by the end of the book, show educators how to support students to fluently reason and represent expressions, equations, and functions, design algebra lessons that are culturally and historically responsive, and much more. It's really an invaluable resource for teachers, perfect for middle and high school algebra and pre-calculus teachers, researchers, teacher educators, anyone who wishes to learn about creating and sustaining algebra instruction that's effective. For a very limited time and exclusively for those in attendance at today's webinar, you can get 20% off the book when you order from us, Teachers College Press, at our website, tcpress.com. When I'm done talking here, I'm going to go ahead and put the details of that discount and that promo code in the chat. So look for that and note it down. You will also find the details of that promotion in a follow-up email that we're going to send in the next few days. So look out for it there as well. Be sure not to miss it. It's an exclusive discount, only valid for about a week, and you won't find it on our website or anywhere else. So write it down from the chat here or look out for that email. And don't miss the opportunity to save on this great resource, the flexibility and strength of which I think you'll certainly see over the course of this afternoon's presentation. If you're an administrator or a school leader, or if you represent a district or are otherwise interested in a bulk purchase for teacher professional learning, you can get in touch with us as well. We'd be delighted to tell you more about the resource and what it can do for the teachers and students in your district. All that said, here to take us through this very important material, and certainly with greater authority than me, we are very grateful to have the book's author and subject matter expert, Dr. Nicole Fonger, who is an associate professor of mathematics and mathematics education at Syracuse University. She is also the recipient of the Linking Research and Practice Award from NCTM, the National Council of Teachers of Mathematics. Thank you for being here this afternoon, Nicole, to share your expertise. If you have questions for Dr. Fonger today, we're going to reserve some time at the end of the hour for a Q&A, so you can put those questions in the chat, and we'll do our best to get to them at the end of our hour. I'll be monitoring that chat throughout, so drop your questions as you think of them, and time permitting, we'll return to those a little later. I mentioned we're going to send a follow-up email where you'll find the promo code in the next few days. In that same email, you'll also find a link to the recording of this afternoon's presentation. That is yours to keep and reference for as long as you find it useful. Please feel free to share it with any colleagues you think would be interested in today's topic. These webinars are free resources that we offer to the community, and there's a lot more where that came from. This webinar, for example, is just one in a series we're doing on math education. Again, after I'm done here, you can look in the chat for more info about the webinar series. I'll put the link there. We're very soon going to be launching a free quarterly newsletter for math educators as well. So you'll find the sign up for that in the chat. Overall, we at Teachers College Press just have a lot of practical research-based materials for math instruction at all levels K-12. So please check us out, get in touch, tell us what resources you want to see. All of this and more you can find at our website, tcpress.com. Again, be putting all of this in the chat for you in just a moment. But that's my time. So without further ado, please hand it over. Please welcome Dr. Fonger.
Wonderful. Thank you so much. Welcome to each of you, and thank you for being here. I'm humbled and excited to be with you for the next hour, and wherever you're joining us from, I'm really glad to be in community with you to discuss some of the joy work that I've been leading for over 18 years. You'll see me sketching on the screen, and so again, I invite you to have a note, something to sketch on, something to sketch with as we go along this journey. So I'll begin with a gratitude practice of expressing thanks to my family, Judson, Everett, Marshall, and Hazel, to my teams at Syracuse University across the mathematics and School of Education, and with a special thanks to the members of the Meaningful Math research group that I lead, the data warriors, and the many algebra teachers that I've had the privilege of collaborating with over the past 18 years. Thank you to Emily and Teachers College Press for inviting me to lead this webinar on supporting students' meaningful algebra learning, the topic of my first book. So I've listed my bio here on the screen and some photos of recent collaborations and relationships with teachers and their students based in Syracuse. The story I wanted to share with you about my identity as an algebra educator goes back to both when I first learned algebra, when I fell in love with mathematical structure and symbolism, and also realized my passion for showing up and succeeding as a woman in mathematics. More recently, my journey in education has centered my collaborative work with high school math teachers and their students, but also a strong commitment to inspiring all learners to experience math and algebra in particular as meaningful to their lives. So with that introduction, really, as Emily introduced, our focus is on understanding some of the instructional practices, routines, ways of reasoning, big ideas of algebra that students encounter and that we have the privilege of supporting in students' path to graduation, knowing that algebra can and does remain a real gatekeeper for many students along that path. So with that as a prime challenge, the motivating question for this webinar is how can we as teachers, researchers, leaders, parents even, support all students to experience meaningful algebra learning? And what I've learned in my career to date is that one's individual journey is not, no one is alone in this, right? We need to work together. So as represented here, not only do we need to work together, but as a community, we need a set of tools to guide our work. And that's really what we're here to talk about today. There's not just one single approach or set of tools. We need a collection of tools. And I'll be arguing throughout our time together that to cultivate all students' meaningful algebra learning requires multiple different perspectives and approaches to moving from supporting students' reasoning and representing to zooming out on the kinds of classroom practices that link our goals, our tasks that we design, and the moves that we make as teachers, as well as practices for inviting students' cultures, histories, and identities into the math classroom as we ourselves, as teachers, journey toward anti-racism as we address and challenge our own biases and orientations toward who belongs in algebra and who has opportunities to learn in ways that are deeply connected to who they are. So here's what we'll spend the next 40 minutes talking about. I'm going to give an equity framework as a framing for our conversation. I'm going to engage in 3 big ideas of algebra: quantitative reasoning about functions, and then multiple representations to be examining both expressions and equations in meaningful approaches. And then finally, I'll close with connecting algebra to the places and people that students learn with and from in their journeys. We'll close with a point of reflection as well, so that you have an opportunity to put those ideas into practice and make note of what you'll be taking with you. So throughout the webinar, I'll be using the terminology of sketch notes and sketch noting. So sketch notes are simply a visual note-taking or note that combine text and image. And sketch noting is the process of that combination of text and image. So I invite you again, if you're not already holding a pen and paper or a stylus in your tablet, to, as you listen and watch, to see how you can capture your ideas on the page in a way that can help unleash creative possibilities. And I'll do some modeling along the way. We know that in solving big problems, big complex problems in our world, that a linear approach is not going to work. We need visualizations. So when we have that visual strategy, then we can ask ourselves as teachers, researchers, leaders, parents, how can we realize meaningful algebra education for all students? And core to building this argument and sharing these strategies is the idea that the lenses or glasses that we wear when we're approaching what counts as algebra, who belongs in algebra, what makes math and algebra meaningful, really taking time to reflect on the lens or perspective that we're adopting as educators is really essential for fundamentally shaping both how we show up for our students in our classrooms, but also the kinds of relationships, connections, and instructional practices that come to the forefront during our instruction. So let's start with that equity framework. Now, today I'll be highlighting the work of Dr. Rochelle Gutierrez. And in her equity framework, please grab your pen and start with an X across your page. So we're going to start with that X from the upper left to the lower right, and we're going to name the upper left access. And you might draw a lock, which is a square with a kind of hook on the top of it to represent access. And here, access is about what are the things that students have ability to experience. So something is unlocked in terms of resources. On the bottom right, we have achievement. And from that achievement, these are the learning goals that we set for our students in our districts. Sometimes these achievement goals are set at a policy level. Many times they are set at a level kind of outside our control, unless we're joining from a perspective that we are deciding what those achievement goals are. The other part of our X is the critical access. So that's the dominant access. Here on the critical access, we're going to frame power in the lower left, which is who has a seat at the table or a say in the conversation. How are people privileged or set up in positions of power? And then the top right is identity. How do students see themselves as math learners in the classroom? And Gutierrez argues that attending to students' identities and power relations are needed, right, to realize meaningful, equitable math learning opportunities. So access is a precursor to achievement, and power and identity must be acknowledged in setting up that meaningful opportunity. So with this framing, what I'm going to help connect is setting up what our work is as algebra educators. So when we're talking about achievement in algebra, we're talking about how students reason and represent algebraic ideas. When we're talking about access, we're talking about what opportunities do students have to learn that are grounded in access to meaningful instruction that link goals, tasks, and moves. And how are students' identities, cultures, and histories supported through experiences that are responsive to who students are? And finally, as teachers, how are we inviting our own journeys to contest with our ideologies and ideas of what counts as algebra and who belongs in that journey? So again, pause and think for yourself, sketch on your page, what is your work as an algebra educator? Perhaps you're thinking about some of the key issues and challenges that you or your students face. So you might note that with an exclamation point and a triangle around it. You might think about how you can get to the big ideas of equations, equivalence, and functions all in a short opportunity, or maybe in the context that you're working in. Perhaps you're thinking about some of the joys that you have as an educator when you're thinking about your students, your context, right? Centering on the joys and the challenges can be a helpful framing as we kind of link to the kinds of opportunities that we're here to build and focus on. I really want this webinar experience to be grounded in your positionalities and what you're bringing to the table in setting up in relation to this broader equity framing. So let's start by jumping in and doing some algebra together. And anytime we do math, it's a good opportunity to remind ourselves and our students, right? This is the identity piece, that we are all math people. And how do you become a math person, or how are you a math person? Well, step one is doing math, and step two is being a person. So when we look at this particular task, I invite you to do some sketching with me. So I want you to sketch a solution in multiple ways. So let's consider this algebra task that's coming from an Algebra Regents exam, which is a high stakes examination that students in New York State are required to pass. Most recently, that restriction has been relaxed in our government, and that's a topic of a whole nother webinar. But when we look at this task, an algebra teacher told me this is a task: f of x equals 3x squared, g of x equals 6x. Solve for f of x equals g of x, or in other words, solve for when is 3x squared equals 6x true, right? What value or values of x make that equation true? And I say the word sketch in particular because you might start thinking about 3x squared as a parabola that goes through the origin, and 6x as a line that also goes through the origin on an xy plane. And when we start sketching that solution, we might come to kind of a more meaningful understanding or approaching it in this way. And in fact, when you ask students to approach this task, some students will start symbolically, right, and divide both sides of the equation by 3 to get x squared equals 2x. They'll subtract 2x from the equation to get x squared minus 2x equals 0. Then they'll factor the equation to get that x equals 0 or x equals 2. We're going to look more carefully at the case of Bea and his equation solving, because even for us as educators, while we might find this equation solving approach meaningful, not all students have that same grounding. So when we look at the case of Bea, Bea is a ninth grade student, algebra student, whom I had the opportunity to do this task with in the context of an interview. We were looking at meaningful equation solving. So for Bea, he really wasn't sure how to approach this task. He said, I like numbers, which is not surprising in that algebra students like numbers, because they've spent much or most of their career in mathematics so far having a very numerically grounded approach to their mathematics work. So we had a calculator, not too dissimilar from the one I have here, and I prompted Bea, okay, you like numbers, then let's make a table, right? So what Bea noticed when he put y equals 3x squared and y2 equals 6x into the table, that an x value of 0, the y values were the same at 0. So he said they have the same 0. Being very curious about how Bea might also be making sense of this visually, I prompted Bea to also think about the graphical representation. So in the graphical representation, he created a graph, and I said, well, what do you notice? And Bea said, they cross. Perfect. So for Bea, he started to make some of the connections across the numeric and graphical representations, wherein he was zoomed in that at an x value of 0, both y values are 0, and at an x value of 2, both y values were 12. So for Bea, he understood these robust connections and even was kind of inputting the 2 into the equation to get 12, the 2 into the equation to get 12 in both cases. When I prompted Bea to think about what did that mean, right? What is the solution? So in this case, what is the solution? One strategy that I use when teaching algebra is to invite students to reflect on and agree or disagree with other students' reasoning. So in this case, Bea was invited to compare his reasoning to the student Janice, who said x equals 0 and x equals 2 are solutions to the equation. For Bea, he wasn't sure. And what stands out to me are some real opportunities and grounding, both some of the joy and some of the opportunity here, that this sameness across representation, Bea knew that the lines, the line and the curve crossed at x equals 0 and x equals 2, but there were opportunities that stood out here to support Bea's meaning making. So I again invite you to reflect on what opportunities you're seeing to support that meaning making, and I'll offer my perspectives on a few places to start. So one place to start is to make symbolic representations meaningful by grounding students' experiences in quantities. So when we think about the symbols, I'm talking about symbols like 3x squared. How do we make 3x squared meaningful? Well, we can ground it in an understanding of 3x squared representing a generalized quantity. So one of our goals in algebra is to support students to symbolize and generalize quantitative patterns by reasoning about relationships among linked quantities. So let's look at an example. So in this example, this task was introduced by Dr. Amy Ellis, a mentor of mine, and she invented a task where students are reasoning about proportionally growing rectangles. From a quantitative reasoning lens, we always want to start by asking, well, what are the quantities, right? So in this case, if we have 1, 2, 3 iterations of this pattern, and algebra teachers, you use patterning tasks, right? So the thing that's a little bit different about this is that we're specifically looking at, we're measuring the height. So one of the quantities that we're measuring, right? We're measuring the height of the rectangle. So in this case, the height is 1. In the second iteration of the 1 unit, in the second iteration of the rectangle, our height is 2 units. Another quantity that we are interested in is area. So this area unit, 1 unit squared, that's 1 unit of area. And then a third quantity that we're interested in is length. And we can see that visually here. In this case, the length is 369 units. Okay, so in a quantitative reasoning task, start by what are the quantities that we can measure and how can we invite students to visualize those. Now the task of moving toward algebra as generalized arithmetic. If we imagine this rectangle keeps growing in a 1-to-3 ratio, and we invite students to make a table relating height and area, if we have a height of 1, the area in this case is 3 units squared. Always attending to the units is really important in quantitative reasoning tasks because we want to ground students' attention to, so this is 3 units long, 1 unit high, and we want to ground students' attention to the relationships between those quantities. So if we then look at a height of 2 units and a length of 6 units, then our area becomes, in this case, we have a length of 6 units and our area is 12 units squared. So notice how I even added something to my table where I wanted to pay attention to all 3 quantities and how they were relating together. Height of 1, length of 3, area of 3. Height of 2, length of 6, area of 12 units squared. This is something with my own kids and my own students that I'm attending to. Well, what are your units in this problem? But how do we connect this quantitative situation to algebra, right? What kinds of questions might teachers ask to move from this patterning activity to algebra? And it really comes to this push for generalization. What is the area when the height is h? And there are 3 common ways that we know from research that students reason about these kinds of quantitative reasoning tasks. The first kind of way students reason is they think about attention to how one quantity is changing. So for example, students might focus on how area is increasing by 9. Well, what we've done in this task, and hopefully you're drawing along with me, is that first we were creating our own tables and our own representations in the rectangle context. We were then inviting students to connect those representations. Another thing that this task pushes us to do is to make a generalization. When we press for quantitatively based justifications, we can invite students to move from not just how is the area changing, but how is the height changing as the area changes, right? How is height changing as area changes? Here, pressing for quantitatively based justifications pushes students to reason about quantities that are co-varying together. And students need those kinds of direct prompting to think about not just the units and things that they're measuring, but the relationships among those quantities. A third form of reasoning about quantities is correspondence type reasoning. And in this reasoning, we're thinking about height to length to area in a multiplicative relationship or mapping. And so when we move to inviting students to generalize mathematical relationships that they identify, they might move by thinking of a generalized height is times 3 to get our length, so that our generalized area is 3h squared. So think about the case of Bea, right? We knew for Bea when he was looking at f of x equals 3x squared, if Bea had been supported to understand this x as a generalized quantity that was grounded in a meaningful experience of dragging a proportionally growing rectangle through a variation, covariation, or correspondence type reasoning, generalized quantity, the meaning of the representations of this quadratic function, right, may have been more meaningful for Bea. Quadratic function. So this is one big idea of algebra, reasoning about functions as grounded in quantitative reasoning. And these are teacher actions that we can take. So in our equity lens, right, the cross from Rochelle Gutierrez's work, if our goals for students are to reason and represent, then our classroom practices have to be opened up to supporting those in ways that are meaningful to students. And we want to ground that, what might be meaningless symbolic manipulation, in quantities and multiple representations. So when we take a multi-representational view to learning, we have to acknowledge that this is a process, right? We want students, they may start with this image on the left where you have some lines crossing, but where we want students to get are this more sophisticated view where they're labeling their axes with precisions, and they're really practicing the canon and the many conventions and norms that algebra students must learn. So students need a lot of practice. And one instructional routine that I've found effective based on my research and ongoing practice myself as a math educator is to set an explicit goal that we want students to communicate like mathematicians by creating, interpreting, and connecting representations. So this reasoning practice and communicating like mathematicians is exemplified in this story. So this is Miss L. She is a ninth grade algebra teacher, and these are her students, ninth grade teacher. And the big idea that these students and this teacher is focused on is the big idea of equivalent expressions. So when we think about equivalent expressions, one strategy this teacher is emphasizing is this create, interpret, connect routine. So Ms. L says, I had students say 3x plus 5 is the same as 1x plus 2x plus 5. Katrina says it is. Ms. L asks why, and Katrina explains because 1x plus 2x is 3x. To her, those are the same. And we hear that is language when we're thinking about equals, right? Or is the same. And in this case, the equal means equivalent. Ms. L prompts, and when we look at our table, Katrina says it's the same equation. And Miss L again prompts, and what happened to our graph? Carlos says it looked the same. So here, the big idea of sameness was really evident in the teacher's strategy for we can look at sameness symbolically, we can look at sameness with a representation of a table, a numeric table, we can look at sameness in the representation of a graph, and students can justify that sameness in their verbalization of equivalence. So the big idea of sameness here was supported by the teacher's practice and focus on supporting math reasoning and representations with fluency, while also using technology as a partner in students' learning. From this zoomed in perspective on students' learning, teaching means inviting students to create their own meaning as an active process. When we want to translate that to something very practical, right? What can I do tomorrow with my students? I invite you to adopt this instructional routine with some question prompts, right? So if we say expression 1x plus 2x plus 5 is equivalent to expression 3x plus 5, we're going to invite both the academic language of equivalent expressions, but then also, how do you know that, right? I know this because in the graph, I can see that 1x plus 2x plus 5 and 3x plus 5 are the same line. Perhaps in algebra, you also have already taught slope and y-intercept, so students might be connecting those terminology and representations to reason that the lines have the same slope and y-intercept. In the table, I can see that because the outputs for my function, the outputs for all inputs are the same. And finally, equivalent expression means the symbols, graphs, and tables are the same. This is a functions approach to equivalent expressions. So functions approach, the reason I sequenced the quantitative reasoning task prior to this equivalence with multiple representations task and instructional routine was so that students make sense of those symbols as generalized quantitative relationships. Those are functions that we can represent with graphs, tables, and symbolic representations, and we can reason about their relationships as equivalent functions or the same functions. So now we're building up to Bea again in his equation solving. And the meaning that if I were to go back and have a conversation with Bea about would be to focus on the meaning of equations as truth values. So this is Miss L again, and in her classroom, she's teaching a lesson on equation solving from a multiple representations perspective, where they were solving an equation after having looked at equivalent expressions and this functions approach to equivalence. Ms. L says, so if I'm not sure by looking at this equation, and this was their equation, 4x minus 9 equals negative 7x plus 13, and we're solving that equation for x. So Ms. L, again, so if I'm not sure by looking at this equation, I can graph these in my CAS. So from a functions approach, we're taking every equation in one variable, and we're comparing the two functions on either side. We're comparing those two expressions as a comparison of two expressions. So we can look at that graphically. So in F1, your calculator might say y1 and y2. We're looking at negative 7x plus 13 and 4x minus 9. Ms. L asks students, what happened to those lines? One student says they overlap, and she restates they sure are intersecting. Ms. L continues, they have a point of intersection, so they have one solution. So again, in the Bea's example, right, this is where intersections of lines from a functions perspective on equation solving emphasizes the meaning of that solution as the truth value, the x value where those functions cross. Ms. L continues, and if I look at my graph, can I figure out what value of x they cross at? And a student says negative 1 and 2. Ms. L adds to that, revoices the student's contribution and says, so x equals 2 and y equals negative 1. We can go a little bit further. We could even annotate on the representation itself that x equals 2, y equals negative 1. What we can see in representations as educators is not some inherent meaning, right? Representations on their own are meaningless. We as educators, as teachers, are inviting students to make sense and meaningful sense of those representations and making those connections explicit in how we're giving voice, how we're using our calculators, how we're drawing on the board, right? All of those are kind of in the sphere of our meaningful instruction so that we're making those connections and interpretations as explicitly as possible. So here Miss L builds on that and asks her class, what if I look at the table and a student says, you can check? Miss L revoices this instructional strategy, right, of creating interpreting, and connecting. She says, that's the way we do it too. You look where the y values are the same, x equals 2, y equals -1. That's the only place. So the solution is x equals 2. So when we look at the y values, this is another point where students can struggle, right? How do I move from a Cartesian or this graphical interpretation or this numeric interpretation in a function table and translate that to the solution in one variable? There's some translating work that needs to happen, right? So when we go back and we say the solution to 4x minus 9 equals -7x plus 13, the solution is not the ordered pair, but it's the x value itself, right? We can verify that by plugging it back in. We see it as the x coordinate on our graph, and we invite students to make that reasoning explicit. So to wrap up this instructional takeaway, one routine that I invite you to look into is called a worked example routine. And you can find many, many worked examples online. So in this case, what I really love about this routine when I do this with my students is it invites me as an educator to specify really clearly for myself what is the mathematics and the mathematical understanding that I want students to have about this particular task? And how can I ensure that they're exposed to those understandings in a way that decenters myself? Right now, I'm doing a lot of talking, right? I'm centering my own voice, but what I'm trying to illustrate is in this strategy, we can show students both correct or incorrect examples and have them reason about that worked example as a starting place for their own reasoning. So the solution to the equation in this case would be 3 minus 2x equals x is what? So when we look at our graph, we see that at an x value of 1, of the y value is 1, the two lines cross at x equals 1. We can see in our table that at an x value of 1, f of x is 1 and g of x equals 1. And we can see verbally that x equals 1 makes 3 minus 2x equals x true. So we invite students in a worked example task to take a look at existing work, to add their annotations, and then create or state their reasoning about an interpretation of those representations. So in the graph, I can see the lines 3 minus 2x and x cross at x equals 1. I know that x equals 1, excuse me. So the solution to the equation 3 minus 2x equals x is x equals 1. I know because in the graph I can see the lines cross at x equals 1. I know in the table because I can see that, again, at x equals 1, f of 1 equals 1, and g of 1 equals 1. Maybe you're not using function notation. Maybe you're saying the y's are the same, right? We can adapt this language to the expectations that we have of our students in relation to their practice in the canon of the discipline. So the solution of x equals 1 means the original equation 3 minus 2x equals x is true at x equals 1. So this is an example of an instructional routine that I found really effective, even when introducing new content, right? Where, especially if one of your goals as an educator, thinking back to that equity framing and what is your work as an educator, if you're looking for more student-centered instruction, worked examples tasks can really be a key thing to incorporate into your routine. And the cost of making them is really a labor of you identifying for yourself what are the learning goals that you have for students. When you sketch that out for yourself, say, here are my goals. I want students to reason about equation solving from multiple representations and to make sense of that equation and the solution to that equation as a value that makes the equation true in symbols, in numbers, in words, and in graphs, then you can design your worked example task to include your own work or perhaps the work of one of your students. All right, so we've talked about access and achievement, but let's get into some other perspectives on making algebra experiences meaningful. I spent a large part of my career focused on equation solving and equivalence, and until more recently, when I started collaborating with some educators who really ground their work in the center of responsive teaching from the position of relationships with students. My perspective on what counts as algebra, what counts as meaningful algebra has really changed and grown. And so here I invite you to consider other perspectives on algebra that really center one of our primary responsibilities as educators, and that is of building meaningful relational interactions with our learners and getting to know them on a personal, mathematical, and community level. So shown here from this heart-centered stance, really, as educators, it invites us to be open and responsive to students' lived experiences and to acknowledge the multidimensional beings that students are and that we ourselves are, and to really focus on that relationality. I'm going to draw some examples from my own work and the work of other scholars. So I'll take first a way to link our conversation about why multiple representations matter to the work of Pamela Seda and Kendall Brown in their Choosing to See, a Framework for Equity in the Math Classroom. And in their book, they argued that it's essential to get to know your students well and to connect their experiences, such as with music, the kinds of representations they're learning in math. We want these ideas to be connected, right? So a student knows that a song can be the background music on their TikTok video. Maybe they don't know what CDs are, but I'm dating myself, but they know what music videos are. They know what a concert is. Maybe they haven't been to one, but they've are looking forward to one or have heard of their friend went to one. They know how to download music, right? These are different representations of a song. Maybe they play it on their violin. And in mathematics, similarly, we want students to understand, just like different representations of music, when we draw the diagrams of the changing rectangles and create the tables and write the equations that generalize those quantitative relationships, and we say those in words, those are different representations or different faces of the same die. If we're holding this die and we think about different faces, just like with music. So this metaphor I find from Seda and Brown's work to be really powerful, especially when we're teaching students, why are we looking at these multiple representations? Another big way to answer the why question is to ground in our identities in the places that we live. So far we've focused on algebra and the big ideas of algebra of functions, equivalence, and equation solving. But what about equations or functions that can be used to model and mathematize our world? I've been really inspired in work with colleagues around this issue, and we've been drawing a lot on Dr. Goldie Mohammed's text of Cultivating Genius. And from her work, we've been inspired to layer multiple texts. So I'm going to show you a brief video as a starting point for an algebra lesson. So I'm going to invite you into this context of the building of Highway 81 in Syracuse.
These are all homeowners on this street here, and the highway is directly behind them. They live here and they hear this noise every day. I-81 was originally built back in the 1950s, and it was designed to last 55 years. And this viaduct that runs through very, very high concentrated areas of people, it is now 2 years past its lifespan. So this neighborhood is a predominantly Black neighborhood that have already been disenfranchised and displaced by the original build, who now have to live 4 to 10 years under construction for a new development in which they feel they hadn't really had a significant voice in deciding what's going to happen in their neighborhood.
So that's a lesson opener for an algebra lesson in which the view of algebra now is as a tool to mathematize our world. From this lens, and Goldie Muhammad argues that before we teach algebra skills, as I just was emphasizing in the first part of this video, we need to connect to who students are and their lived personal experiences. One way we found really powerful in our ongoing work in this area is to connect to the places that students know. Students know this highway. They've driven under it. They either live next to it or know of people who live next to it. Even at the college level, students are where you take the highway to get to the mall, right? So this is a very important issue in our community that we connected mathematics to. So in this case, instead of starting with the mathematics and designing rich context around that, you start with the rich context and design the math around that context. And so we invite students to position themselves as experts on their own communities and bring their practices and funds of knowledge across boundaries in ways that honor their expression and context through mapping activities, through investigating, positioning students as making predictions about their own city, in how they would predict if they were to build a highway back when it was originally constructed in the late 1960s, what might they have predicted? And then continuing into here again comes in, you still get reasoning about change in multiple quantities by, for example, zooming in from a numeric perspective, reasoning about change in years and population of people after the highway was built, right? So the skill development and the intellectual development is layered into the context of students learning in a context that they're very much aware of, and their representational fluency of creating, interpreting, and connecting tables, graphs, and symbols is connected to that experience. This again is echoing that those mathematics skills are layered on after students are invited to connect with the ideas personally. The last example that I'll share from this responsive approach, and I won't play the video for you now, but I invite you, if you haven't yet seen the Hidden Figures movie, to watch the trailer or watch the movie. This is a context that Dr. Seda and Dr. Brown in their Choosing to See book emphasize as a culturally responsive task that centers the work of NASA scientists Dorothy Vaughan, Katherine Johnson, and Mary Jackson. And what they did in arguing for culturally relevant tasks, I'll zoom in a little bit. This is their principle of understanding your students well. And what they argue is that you can take this quote unquote naked number task of solving equations for X. You can instead position students into the context of these NASA scientists, Black women NASA scientists, and computers, and then revise the task to a culturally relevant task where you say, I'm missing a document with an equation that has 3 as one of its solutions. Could this be Miss Jackson's missing document? Explain your reasoning and show your work. Across these examples, what I hope you're seeing is a theme of how to adapt algebra tasks to be culturally relevant, is to invite students to connect their personal histories, places they know, and cultural practices to mathematics. This brings us back to our equity framework of Dr. Rochelle Gutierrez's work, where we're attending to students' identities and the power in shaping both what and how algebra is taught and learned. So to summarize, before we move to some Q&A, I invite you again to engage in some sketching in thinking across the instructional routines and resources that I've introduced today. So one, sketching and sketchnoting, creating sketch notes is a practice and a product that I invite you to take with you as you go, especially as you think about having these conversations with educators and thinking across context from your equity perspective. Another resource that I'm sketching for you now is this equity lens, right? When we think about our access and achievement lens, students are not going to learn what they're not given the opportunity to learn. So access and achievement is really central, but also we hold a great responsibility when we're thinking about Algebra for All of how we're inviting students in to see themselves in the classroom and what power we're giving students to have that autonomy. In the quantitative reasoning task, the connect, interpret, create, interpret, connect, and worked example tasks, those are all examples of routines that are taking that more kind of traditional approach to what is algebra. And then I close with a model of how to start that instruction, starting with students' identities, places they know, and learning about themselves and others before moving to skill and intellect. So I invite you to think about these points of most significance for yourself in your own context, in your own work as an educator. Is your own work focused on designing and sequencing rich tasks around the big ideas of equivalence, equation, and function, and using technology as a partner? Is your own work focused on relationships, relevance, and rigor, which is the big picture model of schooling, wherein students are centered in the relational interactions and students' identities are present in the classroom? When you revisit this guiding question of how might you as a teacher, leader, or researcher realize meaningful algebra education for students, I invite you to really think across these lenses, right? You need to both zoom in on what students are reasoning, zoom out to the access that you're providing them in the classroom, and to zoom out even further about ways you're inviting students' cultures, histories, backgrounds, and your own identities and ideologies as shaping the milieu or what's happening in the classroom environment. So where are you now and what's your vision for the future, right? Again, an invitation that this work is collaborative and necessarily involves using multiple tools in a collaborative way. What we've done together today is really grounded our work in educators to realize goals for students that include visualizing patterns and reasoning about quantities, understanding equivalence and equations as sameness or truth values, and connecting students' identities and experiences to learning algebra. We need to really think about and challenge our own biases of who belongs and who is capable of succeeding in algebra, prioritizing those quantitatively rich multiple representations, and invite students to bring their identities into the meaningful learning experiences. And of course, as we educate ourselves and inform others, thinking visually can, I hope, really serve as a lifelong tool for you as a teacher and leader in this space. I'll close finally with this prompt of a point of most significance. I gave this prompt to my students earlier this week and was really impacted by their responses. This would be a prompt you could give every student every day for a week and just see what comes up. This webinar was meaningful because, or this lesson was meaningful because, right? Allow students to give voice to what's meaningful to them. And if you're not getting meeting the goals that you had set for that, then use that as an opportunity to reflect, to provide opportunities across that equity framework to other kinds of opportunities. I'm happy to share additional resources that I cited during this talk. I'm grateful to the scholarship that the scholars and the scholarship that this work builds on. And I sincerely hope that you reach out. I'd really love to hear from you. I'd love to send you a sticker, and I'm very grateful for your time and presence today. I believe at this point, Emily will be kind of coming back on to help monitor any questions that you have. And if folks don't have questions, before you leave, I invite you to share what was meaningful to you in the chat. Thank you very much.
Thank you so much. That was a wonderful presentation. So great to see you sketching and really, modeling the methodology that you're describing. And I just wanted to say, because I don't know if I made this explicit in my introduction, but the book has a lot of illustrations and so forth, and goes through kind of the sketchnoting practice that you're describing. Um, So as Nicole said, everyone, please do put your questions in the chat. While we wait for a couple of those to come in, we did receive some questions from audience members ahead of time, so we can start with some of those.
Great.
We received a bunch of questions that I'm going to kind of lump here together about, student engagement. What do you do with apathetic students, struggling learners, IEP learners? That's obviously a whole range of issues, but the question that a lot of our attendees seem to have was pertaining to how do you get students' interest and maintain it, and I loved all of the rich context and positioning that you shared with us and showing how to bring it back to their communities and so forth. Does that maybe I'm just asking for it to be too explicit here, but what is your experience with students who perhaps were formerly apathetic and then seeing this approach change? Does it change the way that they engage with math? In your classroom when you do these very contextualized cultural approaches?
Yeah, what we found, especially in the example that we shared on Highway 81, first of all, students are not used to maybe like watching movies in math class, right? They're not used to being invited to connecting their personal experiences in places they know. So when we ask them to position themselves as experts in their communities and their experiences, we found students really engage in a much different way. So that's one way. I think also, that's from a responsive approach. I think another thing that, as you were asking the question, it made me think about, um, you know, we don't see the world in the same way. So what are opportunities? How can we position students as really being experts in their own ways and modalities of learning, and start there, right? And possibly that means expanding to an interdisciplinary approach. And I found that really fruitful as a math educator to say, what can I learn from how this student is experiencing their English class, their history class? How can I invite those kinds of disciplinary practices into the math space in a way that invites um, their brilliance to be centered?
Great, great. We're getting so much wonderful feedback in the chat. Um, another question we received beforehand was about how to integrate the approach with your this approach with the teacher's current curriculum. I mean, I think what you're presenting here can be integrated to any curriculum. Is that fair to say?
I would argue that the approaches here can be integrated with any curricula. I also appreciate, the question of like, what can I do with this? What can I do with this tomorrow, right? How can I use this in my current curriculum? So one way is to look for the layering of the multiple texts. Another way, thinking about the points of most significance, I'll go back to that slide, right? One very easy way is as a warm up or an exit ticket related to the point of most significance, right? What is the big takeaway for today? How could you use one image and one text in one image and one word, right? So if we're looking for that, that would be a great way in any given math lesson that we're saying, what is your takeaway? And that can be a really important tool for formative feedback, especially as we're really trying to assess what are students taking away, what's sticking, and how can I use that as a point to build on students' understanding for future lessons.
Great, great. We received a question in the chat from Claude. Is there any chance of getting this approach in lower level primary? The book, of course, deals with secondary because of the level that algebra is typically introduced. But have you used a similar approach at other levels of instruction in your work?
Yeah, so more, so when I work with pre-service teachers of elementary school of mathematics, I use sketchnoting as a strategy to kind of unleash like creativity, right? So sometimes with younger learners, they may already be disaffected or kind of shut down toward mathematics, and getting them to remind themselves that, holding your paper and drawing is an approach that's available to everyone. I'm smiling because I'm also thinking about the young learners in my life. I have a preschooler and a third grader, and we use drawing a lot. right? Like as soon as we know how to hold a pen, we're like making marks on the page and making meaning from those marks through our drawings. So I think the approach of sketchnoting and visual representations of algebraic ideas are certainly approachable to all learners. We know that algebra is not just a standalone course. Algebra is a way of thinking that is a K-12 concept. And so I really invite you to share back with me. Hopefully you've tried it with your learners, and I'd love to hear how it goes.
That's great. And what a nice note to end on. We're at our time, so I just want to thank you so much for your presentation. Thank you to all our attendees for being here. As I mentioned earlier, please look out for that email. Share the recording with anyone who you think would find it valuable. And please take advantage of the discount on the book for much more even than we could cover this afternoon. So we'll go ahead and say goodbye. Thank you all so much.